Hello and welcome to another episode of Invalid Entry. We're back on the Koche Snowflake today because I like fractals and I do apologise there's a bit of a flicker going on. Basically last time I managed to make the fractal and I picked some coordinates to make the star. I basically picked coordinates which made it look like this. That was my try I had last time. It's a bit bright over here. I need to like my lighting for this a little bit more. So basically this time I'm going to do a better choice. I'm going to best do it for a better number of coordinates as well. So the first thing to do is imagine a circle going around the midpoint. This is a 500 by 500 array, which means that midpoint is 250 by 250. Makes the maths nice and easy. We're going to hard code it in. What we're also going to then do is work out where points are on the outside. So for an n number shape, like just a 3 numbered shape, I believe it's actually going to start it maybe at the bottom here because it's going to be a sine wave. But basically any location on here is going to be divided by a number of degrees around it, and by degrees we actually use radians, which means the full circle has 2 pi radians. The first thing we're going to do is we're going to 2 pi divided by n. That's going to give me my number of degrees round times by, we're going to put times by I, we're going to 4i in range. So we're going to loop around that and we're going to locate these coordinates. Now the x coordinate will be the width out, which we can fix. So if this is going to be 250 from there to the outside, we probably want it to be about 200, maybe about 180, because there may be a line, for example, that goes across there that sticks out. This angle here will be larger than the sort of gaps that will overshoot. You don't want to make this the 250. So the x chord will be sin of 2 pi over n times I, because you want that inside the sin. And you've got to remember what you think of is triangles. Triangles, if you've got an angle there, it's opposite over hypotenuse. We know this here is so sin theta is op over hypotenuse, so we're just moving it to the side to give us that figure there. Actually, this will be the y value actually. So it's times the fixed value of 180, and then the x coordinate will be cos the same thing times 180. So this will be very easy to program it, and then it will work for n things, and that's going to give us an arrays. The next thing I'm going to do, by the way, is I'm also going to change how I render. So instead of rendering the thing, I'm going to use a flip, which makes it render slightly different. We're going to do this live now, so I'm going to flip back to my main mode. And here we go, straight into the code now. So I'm just going to move my cameras out of the way for this. And the idea here is that these coordinates will disappear. So what we're going to do is, we've already got math downloaded. So chords points equals 3. Right, 4i in range points. So the first point we won't be able to do because we need to have a pair. Ooh, all that. So just store the last point in there, and we're also going to have the first point in there as well, right? So calc point new x equals math dot sin math dot pi, 2 of those because there's 2 times radians, divided by points, and then that is going to be times 180. I think actually this was going to be the y, and the x was going to be math.cos. Okay, so new point equals new x new y. There you go. If first point equals none, first point equals new point, last point equals new point, else, otherwise we've already done the first point, and we're going to go chords equals calc star equations, and we're going to go from last point to the new point. Like that. And then get rid of all those. Actually, counter equals counter, because we're counting up and down. And at this point, we can also do last point equals new point. After we've done all those, I believe we will still be a little bit out. So I believe that at the end of this loop, let's put all those in an indent. At this point, after we've done that, we'll also want to do one more, which will be the last point going to, we'll get with that, going to the first point, just to seal it up. I believe. That may double do it. Anyway. It takes 2 position arguments with 3 were given. Calc star location. Oh, these gives us chords. I don't want the counter there. So this is where I want to do draw chords. And the chords are going from the surface to the chords, and I'm going to set the depth as being counter. So let's see if this works for 3. And it doesn't, because that should be screen there, because I just copied and pasted the wrong one. And we get absolutely 0 output, so we're going well to begin with. It's quite possible we actually have to do math.floor on that, because that will give us a I think you can give it float point numbers, but hopefully this will work quite nicely. Now what we're going to do here as well is we're also just going to print off the new point to make sure we're actually getting values coming out. So they're all coming out the same value every time, which suggests that I is not coming around, and here is why. I haven't done times I. Put in first I times that and I times that. Should have looked at my bit of paper that did it. And you see, undo it. Now, I forgot a part. I can see exactly what's going wrong. The part I forgot was this here actually isn't good enough. You want it to be offset by 250. So it's 250 plus that and 250 plus that. Now, sometimes the output of that number, because math.cos and math.stin will be negative. So actually it will go minus it rather than plus it. But that should now give us a star in the front. Now notice it is missing a side, and I had hoped that that would work, and it has worked. It's just I also need to have that line there, so it actually draws the last side in. So there you have a perfect triangle of that. But it also means that it will work going into 4 points. So I can have a square-based snowflake. Notice this one, they're actually going inwards here. Was it going inwards on 3? It was going inwards. I missed that one, and that is very simple to do. All we need to do is say, instead of going from the last point to the new point, go from the new point to the last point. Or rather, go from the new point to the last point, which I think actually will cause it to draw backwards, but it's fine. And then, of course, the very last line there has to be backwards as well. So first point to last point. Right, we've now got a generic snowflake generator which is generating. This is the line there. It's very hard to see with the lines there or the lines there, you see, but that is going really nicely. It will work for 3, it will work for 7. It looks a bit different when you're going for 7 or higher. Now the next thing I want to do very quickly is up here, I want to take these display flip clock tick up here, I want to put it inside of the drawing. So every time I draw a line, I actually want to flip the display. And I'm going to set the clock tick here to being 30. In fact, I'm going to take the clock tick out altogether, so it's going at maximum speed. Because as it gets to the more complicated fractals, you actually begin to get the pattern of how it's actually drawing, building up, and you start to get this animation of it actually drawing, which is really nice. When I was younger, I did a lot of work on fractals, and to be honest with you, the rendering of the fractal was sometimes more fun than the actual fractal itself. And I think I probably will do more on fractals on this channel later. There's some really cool ways you can actually display the calculations of the fractal, which are as beautiful as the fractal itself. You see, it's working its way around, just like I was doing on my pen and paper last time. And as it has less to do on the deeper levels that it's going upwards, it generates it faster. So as it has less complexity, that you can sort of see the speed of calculation, the amount of work it's having to carry out. And also that's why there's not much difference in this layer and the previous layer. You can't really see much difference, especially on this layer, but it takes a lot longer to calculate, so that's a lesson in producing much data. I could now say I want to randomize the number, and I could do some funky things, but I'm actually going to leave it there for today. So that's a nice easy one you can learn. Now the one thing to realise is that now I've got a loop in here where I'm doing display flip. I'm not actually going round and calling this master loop every single time round. I'm actually calling flip. If you put the clock tick in there, it will make the frame rate correctly, but I'm not processing the quit. So actually when I kill it, it goes really nasty. So if I hit the quit now, it doesn't actually quit until then. So it's quite a long delay. So just working how that is. Now I could get around that by instead of drawing here, I could return the coordinates from the draw chord calculation and then do the drawing on a loop here. But I have to restructure my program a bit. So having an idea of what you want your program to do, it really matters. Anyway, if you like this, please hit like, subscribe. There's two things that appear above you, or above me rather. It doesn't appear above you. It'd be very weird if they appeared above you. Click one if you feel fancy to. Otherwise, I'll see you guys tomorrow.